Okay, AMA, we're getting into section 1.4, but just a little introduction to it. We're not dealing with the whole lesson right now. We remember that 1 over small is big, and our learning target is I can determine limits involving infinity. Now, one thing that I want to remind you of is that if you had 1 over x, that was the Kung Fu Fighter graph. Now, what you really need to know is that's true for anything with x to an odd power. 1 over x to the third would look very similar to that. 1 over x to the fifth would look amazingly close to that. Same thing with 1 over x to the seventh, and so forth. Now, if we had 1 over x squared, y equals 1 over x squared, that is the volcano shape. Our y's would always be positive, right? You're squaring you have 1 over x squared, no matter what you plug in for x. As long as you're defined, you'll get something positive. So that's also going to be true if I gave you 1 over x to an even power. So we can definitely get some help there. Wow, my pen is acting up. Let's see, there we go. That's a little bit nicer. So we look here and we can see this is 1 over x plus 3 to the first. This is going to be what, like the Kung Fu Fighter or the volcano? Kung Fu. And we can say, hey, we're going to go 3 steps, X-Files. We're going to slide 3 steps to the left, and it's going to look something just like that. And it says, hey, as x approaches -3 from the right side, where are we going, guys? Positive infinity. How about from the left? Negative infinity. How about if I don't specify a direction? D and E. Now, could we have done this without a picture? Yeah, you bet we could. We could plain and simply say, look, here's the x-axis, and if I'm going just to the left, I'm like plugging in -3.1. Just from the right, it's -2.99. If I plug in -3.1 in the denominator, I've got something very small and something negative. And actually, pardon me, as we go -3 from the right here, I need new glasses. That would be -2.99. I am so sorry to make this all be in agreement. -2.99 would get you something positive. That's why we'd get positive infinity. Look, you don't even need a visual picture there. And if I'm plugging in something from the left at like -3.01, then clearly that denominator is negative, and 1 over something negative small, you're going to get something big and negative. You come over here, you've got your volcano. This is your volcano graph. And it looks just like what we had, except it's going to look more in this direction. So if -3 is approaching from the right, we're going to positive infinity. This thing, gosh, that got messed up. Maybe here's x approaches -3 from the left. It's also going to positive infinity. It doesn't matter what side we're going to. And, we've got agreement, so we'll just say positive infinity. Now, again, you could plug in -2.9 or, -3.1. At the end of the day, you're squaring down there. You've got something small, but the squaring guarantees it's positive. 1 over something small is big, and it's a positive big. Well, now we can take a look at number 3. Is this more like the Kung Fu Fighter or the volcano? Kung Fu. It's odd, right? So we're going to say, hey, shift everything 2 steps to the right. It's looking like the Kung Fu Fighter. And, as we go from the left side, where are we going? Negative infinity. That's kind of like plugging in a 1.9, right? And if you did plug in a 1.9, you could see that you'd get something negative to an odd power down below. So we got a negative infinity. Over here, we're going to positive infinity. It's kind of like plugging in a 2.1. How about no direction specified? DNE, right? Okay, okay, guys, 2 more problems. Take a look at number 4. What kids will quickly notice is they'll say, wait a minute, This doesn't appear to be easily graphed with that x up on top. But I'm approaching 2 from the right. So if you're approaching 2 from the right-hand side, you're plugging in something like a 2.1 or a 2.00001, something like that. The top, of course, is going to be positive. So is the bottom. But this is a positive small number. And when you divide by something small, you get big. And everything's positive. This is going to positive infinity. I don't even need to see a picture to know that. Think we doing okay with that? Last one. Joining example 5 with this bottom thing. They're saying you could make a table. You could bring your calculator up. And, you could clear this out and say 2 minus 1 all over x. You don't even have to do a pretty print fraction. But they want us to see what's going to happen when you plug in 100 and 1,000. Yes? The order of operations would be okay. It knows that you always divide before. If you want to put parentheses around the 1 over x, you're okay. But it's actually not needed here. Okay? So I go to second table set to go to ask. Then I'm going to type in 100. I can type in 1,000. It looks like they're asking me to type in 100,000, I think. I could say, hey, what if I type in 1,000,000? Or a whole bunch of zeros here. That's 1 times 10 to the 8th. Sometimes kids will say, look, you actually get a 2 here. Do you think it's actually a 2? No, you put your cursor on it saying 1.99999. Even down here, guys, you put your cursor on it. The display shows a 2, but at the very bottom, you can see you're getting super, super, super close to that. So, what do you think we're going to have for this limit? It's going to 2, because guess what 1 over x is getting close to as we get super big? 0, right? 1 over big is small. And when I say small, I mean we're getting close to 0. Okay? And that's the end of our lesson today.